Hey there, guys. So, welcome. I know this is a whole new experience, this online learning stuff, but I want to go ahead and give you some tips and tricks and walk you through the first section of your first module. So, this is my dashboard, and on my dashboard is my Algebra 1 distance learning math. I moved mine to the top just so it'd be easier to access. We're not going into any of these other courses that we have. We're just going to go on to distance learning math for Algebra 1. And you've got a whole welcome to Algebra 1, talks you kind of through like how Canvas works. A lot of you know a lot of this stuff already, but it might be worth checking out just to kind of refresh yourself on a lot of this information. But what you're going to do for all the modules is we'll click here on modules on the left. And we have a bunch of stuff. Now, again, we have the welcome module. We have a lot of introduction stuff to kind of teach you about Canvas. More stuff about Canvas. And now here we are, week 1, module pretest, module 8 stuff. So here we are, right? So this is the work that you'll be doing for our first week. And this is, I'm going to talk about in this video, the greatest common factor. We're going to go through 8.1 together, and I'll make a separate video going over 8.2 with you. Now, before you do this, you do want to take the module pretest. So when you click on the module pretest, I think it just kind of gives you an outline of the module itself. Now, don't worry about this stuff. This is for the next 3 weeks. The first week is only going to be 8.1 and 8.2, but over the next 3 weeks, we'll cover all of this. And this is everything that'll be on the pretest. Notice the arrows at the top right is kind of what we'll click through for most of these modules. And at the very bottom, we'll click through to go to the next part of the module. So this is the actual pretest. It's 25 questions, and you guys can go through it. It takes 3 attempts. Now, let me go back to modules real quick. All right. Now the pretest is its own separate one, right? So like this, what I clicked on first, you saw me where it took me. But if I click on the actual pretest where it says 100 points, it takes me to that page after I clicked next before. It takes me to that page where it's got the 25 questions, right? So it just, that's how those next arrows work. When you click next, it's taking you to the next part of the learning modules, right? So let's get into this. After you've taken the pretest, again, don't stress out about the pretest. It's just a kind of a metric to see what you know now. And for a lot of us, we probably won't know how to do any of it. And that's okay. There's nothing wrong with that. It's only a pretest. The idea is so that we can see how much you've learned from the beginning to the very end once you take your final test, wherever that is, okay? So let's get into 8.1 greatest common factor. So this first part here, this is going to be the lesson. And then the second part here is going to be the 10-point quiz. But obviously, we'll jump into the lesson first, and I'll kind of talk you through it, right? I'll help you out a little bit as we go. So first, just how we navigate this. Here's the lesson, and the arrows on the top right again are going to be how we scroll through the lesson. And there's going to be 7 pages of it. Right, once we're done with that lesson, then we'll click next. And when we go to next, you can see it's going to take me to the quiz, the 10-question quiz that I just showed you. But we obviously don't want to do that yet. So let's go through the lesson together. I've got my whiteboard open here so we can work some problems out together. So before you begin this lesson, take some time to review the process for finding greatest common factor of 2 or more integers. So here we're talking about factoring. And one of the main things about factoring is greatest common factor. All right, GCF for short. Now, here's how we find greatest common factor. Let's look at step 1, right? So here, list the prime factors of each integer. Recall that an integer is prime if the only factors are 1 and itself, such as 3, 5, 7, 11. These are all prime numbers because they can't be divided by anything. Sorry, I sneezed for a second there. Just had to mute the mic. They cannot be divided by anything other than itself and 1. That's what makes it prime. Right? The prime factors of any integer can easily be found by using a factor tree. So here you got a couple examples of factor trees. Let me explain exactly how they are working that out. Okay. So with 30, they just picked a random number 30 and they decide, hey, let's try to make a factor tree for it. So how a factor tree works is you take your number and you find any two numbers that multiply to make 30. So for example, they used 5 and 6, right? Because 5 times 6 makes 30. And then they continue factoring this down step by step. So now we look at 5. Can I break 5 into anything? Can 5 be divided by, or is there any two numbers that multiply to make 5 other than, of course, 5 and 1? We wouldn't want to use 5 and 1 because then we just continue the same process of having 5 and 1 repeat. So we don't want to do that. We're looking for anything that's not like itself and 1. And so the answer there is no, right? 5 can't be broken into anything else as far as multiplying goes. There's no two numbers that multiply to 5 other than 5 and 1. So now look at 6, right? 6, we can find two numbers that multiply to 6 that are not 6 and 1. For example, we can find 2 times 3. 2 times 3 makes 6. So now the question is, can I break up the 2 anymore? And the answer is no. 2 is prime. 2 cannot be factored down any further. And neither can the 3. Those are, again, prime numbers. So 30 prime factors are 5, 2, and 3. And that's, as you can see, what they've listed here. That's how their tree is broken down. But you don't have to choose 5 and 6. Let me again show you a different approach, right? So 30 can be done by doing 3 times 10, right? It's going to be a different looking tree, but we'll still get the same factors of 5, 3, and 2. So obviously 3 as part of this branch cannot be broken down anymore. I like to circle it, kind of like put a leaf on it, I like to call it, just to kind of finish that branch off, because that branch is done. 3 cannot be broken down anymore. However, the 10 we can break down. The 10 can be broken down to two numbers that multiply to 10, which are 5 and 2. 5 times 2. Now the 5 can't be broken down anymore. The 2 can't be broken down anymore. They're still prime numbers. And again, you get the same result, 5, 3, and 2. So it doesn't really matter how you break it down. You'll still get the same numbers regardless. Take, for example, one more, like 15 times 2, right? 15 times 2 makes 30. 2 is a branch that can't be continued because you can't break down the 2 anymore. But continue finding numbers that multiply together to make the next chain in the sequence. 15 can be broken into 5 times 3, right? Again, these are all multiples. It's not numbers that you're adding together. It's numbers that are being multiplied together. Okay, factors are numbers that can be multiplied to make these other numbers. 5 ends that branch. 3 ends that branch. And again, you see the same result, 5, 3, 2, right? Same number, so it doesn't matter how you break it down. You'll always end up with the same prime factors. And if you look at 45, same idea, right? Two numbers that multiply to 45. Now they've used 5 and 9, and you can see 5 ends that branch, 3 and 3 end that branch. So 5, 3, and 3 are the factors. But let's choose a different set of numbers just because. Just to show you again, we get the same result. So 45, let's use 15 times 3. 15 times 3 works. 15 times 3 makes 45. 3 is the end of this branch, but 15 we can break down into 5 times 3. And again, 5 ends that branch, 3 ends that branch because they're all prime numbers. You can't break them down any further. So again, you see the 5, 3, 3, exactly the same result. So that's how you factor something. Those are how you find what we call those prime factors. Now, how does that apply to what we're going to do here? Okay. All right, so to find the greatest common factor, here's what we do. We would list out the prime factors. So you can see they've listed out the prime factors. Let me go back to let me snip this. Okay. So you can see for 30, they've listed again the factors were 2, 3, and 5. Remember, we got those earlier. And for the 45, they got 3, 3, and 5. Remember, we got those earlier. Right? So these are the factors of 30 and 45. Now, what do they have in common? Both of these have a 3 in common. They both have a 5 in common. So together, they both have a 3 and a 5 in common, which multiplied together is 15. So technically, they both have a 15 in common. They can both be divided by 15, in other words. So when you look at 30 and 45, the more advanced approach to this, when you're finding a greatest common factor, is What is the biggest number you can think of that divides 30 and 45? The biggest number that divides both of them is 15, right? Both of them can be divided by 3, but that's not the biggest one. They can both be divided by 5, but again, that's not the biggest one. The biggest number that both numbers can divide by evenly is 15. And that's how GCF works. That's how we find the greatest common factor. So there's kind of two approaches to this. There's a slightly more beginner's approach and a slightly more advanced approach. So the beginner's approach, which is what I'd recommend we start off with, is the factoring tree, right? Breaking it down like we did before, and then finding the factors they had in common. That's a very beginner's approach because it's very simplified and it's easy to find. But the advanced approach is just simply looking at the numbers and deciding, hey, can I figure out, and you have to be pretty good with your multiplication, division facts here to be able to do this. Can I figure out what the one biggest number that both these terms can be divided by? What is the biggest number that both of them can be divided by? If you can do that, if you can answer that question, then you can skip the whole tree making process, right? If you can look at these two numbers and go, I know that 15 is the biggest number that divides both of them, then you already know the GCF is 15, and you can skip making the tree. But again, that's a more advanced approach, so I wouldn't recommend that until we've had some practice. So let's get back into the module. I think we should probably practice a few more together before we move on to the next part, because this does kind of take you through things pretty quickly. All right. So yes, before we get into this part, let's practice a little bit. So let's find the common factor between 27, the GCF, I should say, the greatest common factor of 27 and 36. So what is the greatest common factor between 27 and 36? Or essentially, what is the biggest number that will divide evenly into 27 and 36? Now let's try the beginner's approach first. Okay, and then we'll try the advanced approach second. And you guys can see what level you're at. Beginner's approach is making a tree. So let's start with 27. Let's make a factoring tree for 27. 27 can be divided by 9 times 3, right? 9 times 3. Now we know that 3 is the end of this branch, but 9 can be broken down into 3 times 3. So that makes 3 the end of those branches. So its factors are, for 27, 3, 3, and 3. Now if we look at 36, we can do the same thing. Now there's multiple different options you can go. Just pick any two numbers that multiply to 36. For some of us, I think 9 times 4 is a good one. 9 times 4. So if we do that, we can see both these can be broken down. The 9 can be broken into 3 times 3, and that ends that branch. And 4 can be broken into 2 times 2. That ends that branch. So for the 36, we have 3, 3, 2, and 2 as its prime factors. So the GCF is just kind of finding what they have in common, right? It's called greatest common factor. So what do they have in common? Well, they both have a 3. They both have a second 3 in common. And that's it. There's nothing more that they have in common. 27 doesn't have any of the 2s that the 36 has. And the 36 doesn't have another 3 that the 27 has. So all they have in common is a 3 and a 3, which, remember, is all being multiplied, not added. Multiplied together, that means the GCF is 9. So we know that the greatest common factor is 9 for if you're talking about the numbers 27 and 36. Now, the more advanced approach, this really doesn't take any work. You just have to do the math in your head, essentially. Advanced approach is just kind of doing in your head. Answer the question, what's the biggest number that will divide 27 and 36? And the one number that divides, or the biggest number that divides 27 and 36 is 9. There is no number that will evenly divide 27 and 36 other than 9. 27 divided by 9 makes it 3. 36 divided by 9 makes it 4. But there is no number that we can choose bigger than this that divides both 27 and 36. So it's really just more, the advanced approach is really just kind of being able to process this in your head. But if you're not very good with multiplication or division facts, then making a factor tree like these can be very, very helpful because you just factor the tree all out. Remember, it's very important maybe you circle the ends of the tree, the branches, because those are the numbers that you're going to list down here. And you just find out what they have in common, okay? So remember, that's how you do GCF. If you want to pick a few more numbers and work it out, you're more than welcome to, right? If you have other questions, you can ask them in the discussion board. If you want me to see more examples, you can ask me in the discussion tab, okay? Discussion is where you can ask questions. All right, now let's look at part 2. Now that you are an expert at finding the GCF of integers, let's explore how this knowledge helps you with algebraic expressions. Then think back to when you first learned how to use the distributive property. Test your memory in applying the distributive property to the expression below. Check your answers to see if you are correct. So they have 4 parentheses x plus 2. All right, I'm going to pull that up here. Oh, I didn't want to go to this one. Let's do a new whiteboard. All right, so they have 4 parentheses x plus 2. So back when we distributed means take the number that's outside the parentheses and multiply it, because it is being multiplied, it's 4 times that group of parentheses, multiply it to both parts of the parentheses, both terms inside the parentheses. So, for example, we would first do 4 times x. 4 times x is 4x. And then we would do 4 times 2, the next term in the parentheses. 4 times 2 is 8, so we'd have 8. And since it's positive 8, we leave this as plus 8, 4x plus 8. So that is distributing, right? We've done this before. You guys should be pretty good at it, but just as a reminder, right, that's how we distribute. So if we check our answer, there you go, right? That's exactly what we just did. So hopefully you guys can do that too. You should be very confident with this process since, you spent a lot of time multiplying polynomials. Doesn't it make sense that you know how to go one way, which is multiplying them together, the 4 times x, 4 times the 2, that you should be able to go the other way, which is division, right? In other words, would an astronaut be considered successful if he made it to the moon but couldn't find his way back to Earth, right? He can go one way, but he should be able to go the other way as well, right? Go to the moon, but then also back to Earth. So that's what we're doing. If we can go one way, if we can multiply these together to make this, right, there should be a way that we go back. Okay, and that's exactly what factoring is. And that's how factoring by GCF is going to do it. The way we go back is by factoring. And in this case, factoring by GCF. So we're going to talk about how we do that. It's very simple. It's the opposite of what we just did, essentially. So let's go through this slide here, right? Answer each question, select check answer to see if you're correct. So think about it. If you are able to simplify the expression 4 times x plus 2 by multiplying the two factors, which is 4 and x plus 2, multiplying those together, how do you start with the product 4x plus 8 and determine the factors used to find that product? And the answer, again, is the greatest common factor. It's going to be the opposite of the distributive property. Answer each question. Yeah, we already did that. Suppose you are given the binomial 4x plus 8, which is what we have, right? And you're asked to find the greatest common factor. Remember, when finding the GCF, two integers, the question is, what is the largest integer that divides evenly without a remainder into both integers? So the difference here is that you are looking for a GCF of the two terms instead of two integers. But the question remains the same. What is the largest term? Again, this is the kind of advanced approach, right? What's the largest term that divides evenly into both terms? All right, so let's do the math here, right? So how do I go from 4x plus 8? How do I turn this back into 4 parentheses x plus 2? How do I do that, right? So here's our approach. We look at the two terms. We have 4x and we have 8. And again, I'll try the beginner approach and I'll try the advanced approach. Okay. So the beginner approach is we look at both terms individually, 4x and 8. And we make a factoring tree. So 4x, we start, at least we know this is 4 times x, right? So we'll break it up into 4 times x. Now x ends this branch simply because we can't break x into anything else, right? It's going to be x times 1. So we'll just leave that branch there. But the 4 we can break down a little bit more. 4 we can break down into 2 times 2. And 2 are both prime numbers, so that ends that branch. So our factors of 4x are 2, 2, and x. If we break down the 8, we could break it into 4 times 2. So the 2 is at the end of that branch, but we continue to break the 4 down. 4 is 2 times 2. And that's the end of those branches as well. So for 8, it's 2, 2, and 2. So now we find what they have in common. Well, they both have a pair of 2's. They both have a second 2 in common. And that's where it runs out. The 8 does not have the x that the 4x has. And the 4x does not have another 2 that the 8 has. So what they have in common is a pair of 2's. They have one pair of 2 in common, and they have a second pair of 2 in common, which means multiply them together, and you have a 4 in common. So the GCF here is 4, which means that the biggest number that divides 4x and 8, the biggest number that divides 4x and 8 is 4. So how factoring works is we divide these two numbers by that GCF. The biggest number I can divide both of them is 4, so I'm going to divide both terms by 4. Now, what I do with that 4 is I take it out of these two terms, right? Imagine that those two terms are already in parentheses, right? We're going to divide by 4. We're going to remove that 4, not completely, not entirely. It doesn't disappear, but the 4 comes out of those parentheses. And it comes out as 1, not 2. Yes, I see that there are 2 4's here, but it's just the fact that they both had a 4 in common is the reason we're taking it out. When we put the 4 on the outside here, we're saying they have a 4 in common. Okay? We don't have to put both of the 4's. We just understand that they both have in common. So now what's remaining of that group after I've divided both terms by 4? Well, if I did 4x divided by 4, I'd have simply just 1x, right? Because 4 divided by 4 is 1. So I would simply just have 1x. And the second part, 8 divided by 4, 8 divided by 4 becomes 2. So that would become a 2. And you can see we've ended up back where we started at 4 parentheses x plus 2. So this is how factoring by greatest common factor works. You figure out the most important part is to figure out what the GCF is, but the actual factoring part is here, where you divide that GCF out of the two terms. So if the more advanced approach is simply just saving yourself the time, right? To be advanced at this, you have to be able to just look at the two terms and think, okay, what's the biggest number that will divide 4 and 8? I know they're both divisible by 2, but 2 is not the biggest number you can divide out. Both of the numbers can be divided by 4. So that's what we do, right? We take this 4. Remember, imagine the parentheses are on those two terms. Both of these can be divided by 4. So we take this 4 and we bring it outside, right? And then we do the math for the remaining part of the group. If I divide that term by 4, 4x divided by 4, remember, it just becomes 1x. If I divide 8 by 4, 8 divided by 4 becomes 2, remember? So we end up with 4 parentheses x plus 2. And again, you should be able to work backwards. We already showed you that when you distribute this back in, you get the 4x plus 8. So it's basically just a back and forth of this. Being able to distribute them together to get 4x plus 8, or factor them apart to get 4x plus 2, right? It just goes back and forth and back and forth. Okay? It's like taking 5 and multiplying it by 2, and then dividing it by 2, and then multiplying it by 2, right? It just goes back and forth and back and forth, right? But the advanced approach is just more or less kind of what you can do in your head, right? Let's practice just one more real quick. I know it's, dragging on a little bit, but I just want to make sure you guys are clear on how to work everything out. Let's try to factor out 3x plus 12. And let's try to do this with the advanced approach, okay? So the advanced approach is asking, what's the biggest number that divides 3 and 12? Now, the biggest number that divides 3 and 12 that I can think of is 3. 3 will divide into 3, of course, and 3 divides into 12. So the biggest number I can divide here is 3. So how this factoring works is I take out the 3 that I can divide by, and I throw it out front. And I put these parentheses in its place. Now I have to figure out what's left of the original terms. So 3x divided by 3 is going to become 1x because the 3 divided by 3 is 1. However, the x is still going to be a part of that term. So we still have 1x. For the second term, I have 12 divided by 3. 12 divided by 3 is 4. So what's going to be left here is 4. And now we're done. We have our final answer. It's factored into 3 times, parentheses, x plus 4. And remember, it should work both ways. So if you took your answer, 3, parentheses, x plus 4, and you distributed, you should get the exact same thing we started with. Remember, because these go back and forth and back and forth. 3 times x would be 3x, and 3 times 4 is 12. So you get 3x plus 12. You get the same thing we started with. So because we're just going kind of back and forth, okay, from one form to the next. So that's our approach, okay? That's factoring by GCF kind of in a nutshell. You can see they've listed everything out here. I've explained this whole thing, but you guys can read it, right? 2 and 2 are common factors. I showed you that from the factoring tree, which meant the GCF was 4. And that means you could divide both terms by 4, right? To do this, you want to factor a 4 from both terms. When it says factor a 4 from both terms, it means divide a 4 from both terms. It's the opposite of the distributive property. Remember, when you distribute, you multiply, right? But when you're doing the opposite of distributing, we're dividing. So distribute, let's write this down actually. So distribute, as we did here, distribute is to multiply, but factor was this way. Factor is divide. So when you distribute something, you multiply. When you factor something, you divide. Okay? Because remember, they're opposites of each other. All right? We could try a few practice problems. So I'll let you guys kind of explore this a little bit. 5x plus 25, you guys can check your answer. There's a few of these, so give them a go. Remember, you can either try the beginner method where you break it into a factoring tree, or try the advanced approach, which is kind of more in your head, if you will. But you guys can give that a try. I'm going to move on to the next slide. All right, so here we have a bigger group, right? Factor completely. 3x to the 5th, 9x to the 3rd, and 12x. So let's put this on my thing, right? We have 3x to the 5th. We have 9x to the 3rd, and 12x. So now there are 3 terms to consider. 3x to the 5th, 9x to the 3rd, and 12x. So if we try the beginner approach is simply, I wouldn't recommend it here just because I think we got all kind of handle this in our heads a little bit. But we could try it, just at least for this first example. It'll take a little bit of time, but we can do that, right? This is going to be 3 and then times x to the 5th. Now, x to the 5th means x multiplied 5 times together. So I'm just going to write this all out as x 5 times, right? So we have 3 and then 5 of these x's. That's 3x to the 5th. 3x to the 5th is 3 and then 5 of the x's. 9x to the 3rd. 9x to the 3rd is, of course, 9 and then x to the 3rd. Now 9 breaks into 3 times 3. x to the third is just x 3 times. So 9x to the third will be 3 times 3 times x times x times x. And then the last one, 12x, we can break into 12 times x. X is obviously just one x, so it's all by itself, just a single x there. It's not like 3 of them or 5 of them like the first ones. 12 we can break into 3 times 4 though. So 4 can be broken down to 2 times 2. So we have a big tree here, right? So for 12x, we have 3 times 2 times 2 times x. So for the GCF, we're looking for what do these all have in common. So I have a highlighter, I do. So all of them have a 3 in common. All of them they don't have any other numbers in common because the first one doesn't even have any more numbers, just a 3. They all have an x in common. And I think that's it. It has to be between all 3, remember. All 3 have to have this in common. It can't just be a pair of 2. Okay? So it has to be between all 3 terms. All 3 terms only have a 3 in common and an x in common, which means the GCF is 3x. Okay? Now, if we look at this from a more advanced approach, 3x to the 5th plus 9x to the 3rd plus 12x, we ask each other, hey, between these 3 terms, what's the biggest number? Let's break it into 2 parts, numbers and x's. What's the biggest number that divides 3, 9, and 12? All 3 of those, right? The biggest number that divides all 3 of those, 3, 9, and 12, is 3. I can divide 3 by 3, I can divide 9 by 3, and I can divide 12 by 3. There's no bigger number that will divide all 3 of those terms other than 3. And the other part is, okay, the x's. How many x's do the terms have in common? The first term has 5 x's, the second term has 3 x's, and the last term has 1 x. So between them in common, they all have at least 1 x. Okay, I'm taking the smallest amount in the pair, because remember, if you look at our tree down here, right, essentially what we're doing when we're looking at this is what do they have in common? They all have 1 x at the very least, but they don't all have 2 x's, right, because 12x doesn't have another x with it. It's not x squared, right? Not all terms have 3 x's, not all terms have 5 x's. They all have at least a single x though. So the GCF is 3x. The biggest number they can divide, 3, 9, and 12, is 3. And the most x they have in common is just 1 x, a single x. So 3 and then x to the first power, or just x. So you can figure the GCF out that way, right? So either way, we've now got the GCF is 3x. So now remember, we imagine this whole thing's in parentheses. This 3x is coming out of that parentheses. So it's going to sit all the way on the outside. That GCF that we just got sits on the outside. Now, what's left in the parentheses is what we get from dividing. So when we let's look at this one term at a time. Let's look at the first one, right? We have 3x to the 5th divided by 3x. So 3 divided by 3 is going to become 1. And then when I have x to the 5th divided by x, what happens here is that essentially you're saying you have 5 x's, remember, and 1 x. So you're taking this x out. When you're dividing, you're taking it out. So that 1x is going to cancel with 1x from the top. And now there's nothing left to cancel. I'm just left with 4 x's. So I'm left with 4 x's. So it's 1x to the 4th. You'll see what I mean when I do the next one, right? We'll try this again. 9x to the 3rd. We have to see this one. 9x to the 3rd divided by 3x. So when I do this, 9 divided by 3 is going to become 3. And then remember, on top, you have 3 x's on top here, and then 1 x on bottom. So you have a pair of x's that cancel, and then we're left with 2 x's, which means it's x to the 2nd power, so 3x squared. And then the last one, 12x divided by 3x, this one here, 12 divided by 3 is going to become 4. And if you have 1x on top and 1x on bottom, then they both cancel out, and there is no more x here. It's just simply going to be the 4 all by itself. And we have our final answer, our final factored form. We're definitely going to want to take a look at another example of that because it is kind of a lot to look at in the first go. So let me see what we have on our slides here. So, of course, they have a video here that you're welcome to watch. Let's try it. Let's do maybe this first one that gives us together. And then you guys can try some of the other ones, right? So 5x to the third minus 15x plus 10x. So 5x to the third minus 15x squared plus 10x. So let's just try this advanced approach, okay? See if we can do it. So let's look at the three terms we have here. We have 5x to the third, and then the minus, we'll count that as a negative, so negative 15x to the second, and then 10x. So let's look at the numbers. So if you're going to try the advanced approach, try it in two stages, numbers and then variables. Okay, so first, numbers. 5, negative 15, and 10. What's the biggest number that will divide all three of those numbers, 5, negative 15, and 10? The biggest number that will divide all three of them is 5. 5 will divide by 5, 15 will divide by 5, and 10 will divide by 5. So if you're good with the advanced method, that basically means that you know your multiplication table pretty well, and you know how to divide pretty well. So the biggest number I can divide by here is 5. Now let's look at the variables. What's the most they have in common with variables? The first term has x to the third, which means it has 3 x's. The second term has x to the second, which means it has 2 x's. And then the last term just has x, so it just has 1x. So as far as what they have in common, they each have 1x in common. They each have at least an x. They don't all have 3 x's like the first term has. You know, they don't all have 2 x's like the second term has, but they do all have at least an x, right? Obviously, the first term has a few more than that. It's got a couple extra. The second term has a few more than that, but they all at least have a single x in common. So remember, when looking at variables, one go-to trick is simply find the lowest amount, and that's the one that they all have in common, right? So the lowest amount is a single x, x is the first power. They all have at least that one in common. So our GCF here is 5x, or 5x to the first power, 5x, right? So how we factor this out is we're going to take this 5x that we can divide out and throw it to the front. Don't forget that. It's a very important step. A lot of times people go straight to the dividing, and they forget to put the 5x in front of the parentheses. So it's very, very, very important you put that out there. Remember, this is your GCF that's going out here. Okay, now what's left over, we have to actually do the division for. So let's do the first group, right? We have 5x to the third divided by 5x. So when you do this, 5 divided by 5 becomes 1. And then here we have 3 x's on top and 1 x on bottom. So if we work that out, 3 x's on top, 1 x on bottom, we'll have one pair that cancels, and then that leaves us 2 remaining. So x to the second power remaining. So 1x squared, or x squared. Look at the second group, we have a negative. Don't forget that negative. That minus sign is very important. Negative 15x squared divided by 5x. Now the numbers, negative 15 divided by 5 is negative 3. 5 goes into 15 3 times, and it's a negative value. Now let's look at the x's, right? You have 2 x's on top, and you have 1 x on bottom. So when you cancel a pair of x's out, you'll have 1 x remaining on top. So that's going to be just 1 x remaining is just a single x. So we have negative 3x. And for the last one, we have 10x divided by 5x. 10x divided by 5x. So 10 divided by 5 is 2. And then you have 1x on top. You have 1x on bottom. So they're both going to cancel each other out, which means there's no x left over there. It's just going to be that 2. And you have your final answer, which is 5x, and then in parentheses, x squared minus 3x plus 2. Okay, so find the GCF, right? And then divide the GCF. Find it, divide it, okay? So there's a problem there that you guys can work out. Let's move ahead. Did I click it? Did I click it? Did I click it? I don't think I clicked it. Hold on a second. There we go. I clicked it for sure. All right. Factor the trinomial. All right, we have a bigger one here, right? It's got a lot of steps to it, but let's explore this one again on my whiteboard. So we have negative 6 x to the fourth y. Scroll down more. Okay, negative 6x to the fourth y. Now that is one term. What other terms do we have? Minus 9x to the third y squared. Minus 9x to the third y squared. And then last one is plus 3x squared y to the third. Plus 3x squared y to the third. So there are three terms here. It looks like a lot, but they're essentially just three terms. We have this negative 6x to the fourth y. Then we have negative 9x to the third y squared. And then we have 3x squared y to the third. Three terms. All right. Remember, let's do this by one stage at a time. Let's do the numbers. And then we'll do the variables. Now the variables, we have two different types. So we have x's and we have y's. So let's do those one at a time. It'll be fine. Let's look at the numbers first, right? Just focus on the numbers. You have negative 6, negative 9, and 3, right? Negative 6, negative 9, and 3. So what's the biggest number we can divide out of negative 6, negative 9, and 3? Now, if you just think about 6, 9, and 3, the one number that you can divide all three of those by is 3. Everything here is divisible by 3. Now, I will say, if this last part was a negative 3, if that was a minus sign there, I would have divided out a negative 3 on all these terms. If every term was negative, I would have divided by a negative. And a lot of times people still divide by a negative. If the first term is a negative, a lot of times people will divide by a negative anyway, just so they can make the first term positive later on. But that's not something that's entirely necessary, but it is something you might see. So sometimes you can divide by a negative, but I would definitely divide by a negative if every term here was negative. But we don't have that. We have a negative 6 and negative 9, but a positive 3. Like I said, if that was a negative 3 down there, then for sure I would have divided by negative 3 all the way across. So the numbers are easy, right? I can divide by 3 for all the terms. The negative 6, the negative 9, the 3. I can divide by 3 for all of them. Now, let's look at the x's. How many x's do they have in common? The first one has 4 x's, right? The second one has 3 x's. Oops, not x squared. It's just how many, right? There's 4 of them here. There's 3 of them here. And then there's 2 of them here. So what do they all have in common at the very least? They all have at least 2 x's in common, right? 2x squared is the smallest one. They all have at least 2 x's. So I can take out x squared from every single one. X squared is to indicate, hey, I can take out 2 x's from every single one. Now we also have y's in common here. So let's look at how many y's each term has in common. The first term has 1 y. The second term has 2 y's. And the last term has 3 y's. So at the very least, they all have at least 1 y in common. So we're going to take that out as well. Add that to our GCF. So our GCF is 3x squared y, right? 3x squared y. That is our GCF. You can see that that's what we're dividing out of all 3 terms. Because every term can be divided by 3. Every term has at least 2 x's that I can take out of it. And every term has at least 1 y that I can take out of it. So 3x squared y. So when I do this math, I'm going to take this 3x squared y and pull it out. And don't forget, it's very important that we put this all up front. This is our GCF, 3x squared y. It's going to come in front of this entire group. So it's very important we have this there. Remember, that is our GCF. Now, the trick is, let's divide the rest. It looks like a hot mess, but we can divide this. So let's look at the first term, right? Negative 6x to the fourth y is being divided by 3x squared y. So when you divide, let's do the numbers. Negative 6 divided by 3 is negative 2. We have 4 x's on top, 2 x's on bottom. So if you have 4 x's on top and 2 x's on bottom, then you'll have 1 pair cancels, 2 pair cancels, and that leaves you 2 extra on top. So you have 2 extra x's. Now you also have 1 y on top and 1 y on bottom, which means that they'll pair up and they'll cancel, which means there's no more y in that term. So it's simply just going to be negative 2x squared. Let's look at the next group. The next group is negative 9x to the third, y to the second. And again, it's getting divided by the GCF of 3x squared y. So the numbers -9 divided by 3 is -3. This one has 3 x's on top and 2 on bottom. So if you have 3 x's on top and 2 on bottom, then that pair will cancel, and you're left with just x to the first, 1x there. It also has 2 y's on top and 1 on bottom. So 2 y's on top, 1 y on bottom. This will cancel, leaving you with 1 y. So it's going to be -3xy. So -3xy. And then our last term, 3x squared y to the third, 3x squared y to the third being divided by 3x squared y. Remember that was our GCF, right? We're doing this one right here. 3x squared y to the third divided by 3x squared y. So 3 divided by 3 is simply 1. X this squared divided by x squared. So you have 2 x's on top, 2 x's on bottom, which means that'll cancel, and there's no x's left over. So there is no x in this term. But we do have 3 y's on top and 1 y on bottom. So 3 y's on top, 1 y on bottom. You have this pair that cancels. You have 2 y's remaining, so y to the second power. So just 1 y to the second power. It is positive. So there you have it. 1 y to the second power. You can write the 1 there. You don't have to. It's all right. 1 y to the second power. And that's our final answer. 3x squared y, -2x, in parentheses, -2x squared minus 3xy plus y squared. Now, what you should notice about your final answer is that inside the parentheses, there is nothing else that all three terms have in common. You'll notice not all terms have x's, because the last term, the y squared, doesn't have an x. Not all terms have a y, because the first term, -2x squared, doesn't have a y. And there is no number that can divide the -2, the -3, and the 1. So there is no more in common, which means we've done this correctly. The GCF has been all taken out. There shouldn't be anything left in common between the terms that are inside the parentheses. So that's just a good way of checking. If all the terms still had an x, for example, then I would know that I didn't factor it all the way, because there is something else that they still have in common. So greatest common factor means you're taking out the greatest common factor, all the common factor. So if you leave a common factor, it means you didn't do right. Just to quickly explain what I'm trying to say. So remember the 4x plus 8 we did earlier, right? If you only divided these by 2, remember we divided it by 4. If you only divide these by 2 and take this 2 and put it out here, then you're going to be left with 4 divided by 2, which is 2x, 8 divided by 2, which is 4. Right? Now this is good. It's factored, but it's not factored completely, because what's left in the parentheses, these terms still have something in common. Both of these two terms can still be divided by 2. There is still a common factor between them, which means it wasn't factored all the way. So that's what I'm talking about. You want to make sure you don't do this, where you leave factors on the table. You want to make sure that when you do this factoring, you do the biggest factor first. So that way you don't have any more common factors between the two terms. There's nothing else that the x and the 2 would have in common. Okay. Now that's, again, for the most part, that's GCF right there. Is there any other examples? Okay. So here again are some questions. I'll let you guys kind of go through them. You do have to click and then hit next. So that's good practice. All right. Here you've got like a matching thing, which is cool. So remember, just good practice. You're going to have to factor these, each of these, and then how does this work? Do you just drag and drop? I don't know how this works. I guess you don't drag and drop. I guess you just have to work it out on paper and then just see if you're correct. I think there's a way you can check your answer. I'm not entirely sure. Oh, okay. You click on it and then you click on the match, I guess. Okay, that makes sense, I suppose. All right. Hopefully I did it right the first time. But once you're done with that, click the next one. Right, and then make sure you review this before you take the quiz. You don't want to take the quiz just yet. Make sure you study a little more, practice a little more if you need to, rewatch the video, hit next when you're ready, and take the quiz. Okay, I'm sorry this was a little bit long. I did want to be very thorough though with it. So if you have any questions, if you need any help, please see me in the discussions tab. I'll be happy to answer any questions you want to leave me here. I'll make video responses. I'll do whatever you guys need me to do. Okay, so without further ado, you guys go ahead and I'm going to start making a video for section 8.2. See you there.